Okay, now I'm going to table 2 where I have some data that I've put together for to go into that table for determining the density of the unknown solution. In this case, I put that it was solution A. It may or may not come out to actually be your solution A, but that's okay. The format will be the same. So I put a known volume into the graduated cylinder and measured that, and then put it on the balance and measure, determine the mass of the actual solution. So I can get the density. So I'll type in equals mass. I'll click on the mass cell, divided by volume, enter. And I can't have that many sig figs. I can only have 3. So I need to reduce that to 3. And then I repeat that for those cells. Check the sig figs, so all 3. So that's good. Then I can average those. So this equals the average. And just go ahead and select my data. So there's my average. Standard deviation equals STDEV. And that's going to reduce down to the same number of decimal places, but it'll go away if I do that. So I'll leave one more just to show there is a standard deviation. So I have that, and there's my average density determined by just adding progressively more volume of the unknown and getting the new mass every time. So pretty consistent as far as the numbers I picked, but right here. But now we need to use that density value. So I'm going to go back to my actual tab for my graph here. There's my equation. This is my slope, this is my y-intercept, and I'm going to just plug that in. I'm going to copy the equation part of it and just Control C, and I'm just going to paste it right here so I can see it. So the concentration of NaCl in unknown, this I was saying was A, and I need to fix that where it'll actually show up what I just wrote. This is my slope, right? So I need to determine concentration. I know my average density is right here, right? So this is very important. So based on what I have here and what I have there, I'm going to type from my equation there, I'm going to type out the word slope, and I'll put that number right here, 0.008. And I might have known that slope better than that, but I didn't push it on more significant figures, because those 2 zeros are just placeholders. But yeah, I have something I want you to do anyway at the end. So the y-intercept is 1.005, and then in this box right here, right beside the concentration of unknown, I'm going to do the math. So this equals, remember it's going to be the density minus this divided by that. So in parentheses I'm going to put first the density and minus the y-intercept, but I don't want to pick from there. I'm going to pick it from here. Close my parentheses, divided by my slope, 11%. But what I'm going to ask you to do is I'm going to ask you to give me the concentration in percent by mass and with 2 decimal places. That's what I want, 2 decimal places. So I'm going to actually increase the decimal, or change it to 2. Actually, mine come out to exactly 11%. So I'll type in the next box percent, and I'll just parentheses. I'll put W like that, and I will red and highlight those. So that's going to be that part. And then I believe I told you that what your concentration was. So I also want you to do a percent error. Well, actually you only need 2 R's. Percent error calculation, and determine that for me as well. And I want you to put that in your Excel document. So based on the concentration I told you that it was, compare your experimental concentration with that. And then the last thing, you have an evaporation method table, and I didn't have any data for that I kept from you guys, but if you type in yours the mass of solution that you used and the mass that you had remaining after you did the evaporation, and I can I'll put some numbers in here for you, and we'll just see how that turns out. But with yours, I want you to calculate an average and do another standard deviation, and do a comparison between this method and the other. So if you had, first of all, a mass of solution that you used that was 4.6453 grams, and then after you you got done evaporating it, and you let it cool down, and you put it back on the balance, and you came back and measured it and subtracted out whatever the mass of the evaporating dish was, and you had, I don't know, let's say for that you had 0.5096, and then you have some numbers here. So you say, I'm going to calculate percent sodium chloride by mass for this. All you have to do is take your mass of sodium chloride divided by your mass of solution times 100. So this would equal that divided by that times 100. And for some reason it didn't take, so it equals that divided by that times 100 equals, and this one you get to keep 4 sig figs, so reduce the decimal to 4 sig figs. And then when you do all of yours, however many you did, if you just did one, then that's your average. If not, if you did more, then you can average them. So then compare this number by doing a percent error calculation with the actual value for it as well. So I want you to report that on this percent error for this method compared to the actual I gave you, and tell me which one's better.